part 1 video for 4-4 adding and subtracting rational expressions. So in the last unit, we looked at multiplying and dividing, and now we're going to move on to adding and subtracting. And just like with fractions that don't have variables in them, the adding and subtracting is going to add an additional layer because you do need to make sure that you have common denominators before you can combine your numerators together. So our essential question, how do you rewrite rational expressions to find sums and differences? So our first example covers some easier topics here. You can see in part A, both of these fractions, well, I'm adding them together because it says what's the sum, but they both have denominators of x plus 4, which means x plus 4 is going to be the denominator of my answer. So once you have that common denominator, then you can do whatever the operation is, in this case addition, to the numerators. So this is going to be x plus 5. There is no simplifying that we can do here. You cannot cross out the x's because the x is attached to the addition of the 5 and the addition of the 4. You can't just separate it from that. The only time you can cross out is if you have factors. And x is not a factor of either the top or the bottom of this fraction. So this would actually be your solution. There's nothing else we can do there. Part B, you can see I have two fractions, again, that I'm adding together. It might look like the denominators are different here. However, the denominator of the first fraction has the greatest common factor of x. So we can actually take that out, and when we take that out, you can see that they are, in fact, identical, which means I can add my numerators together. So you want to combine like terms. 2x plus 3x is 5x, and 1 plus -8 is -7. There's nothing I can factor out of the top. It does not have a greatest common factor, so there's nothing else I can do with this. That would be your solution. So it is pretty easy to combine whenever your denominators are the same, but whenever they are not the same, then you need to consider what the least common denominator would be. And when you're doing the least common denominator, you want to consider the least common multiple of whatever the denominator happens to be. So with this example, we have two different polynomials, and we are going to come up with the least common multiple of the pair, or in part B of the triple, of the three of them that are there. So you need to account for every factor, and you need to account for every factor to the highest power. So my first polynomial here, x plus 2, that's already squared, so there's nothing else that we can do with that. With the second one, x squared plus 5x plus 6, that is going to factor into x plus 3 and x plus 2. As a rule, whenever you are finding the least common multiple, every factor has to be present, and you have to use the highest exponent of every power, or of every factor. So the first set of parentheses I have is x plus 2. Notice it occurs with the first polynomial and with the second polynomial. The highest degree is 2, so 2 is what has to go in my least common multiple. Because I can multiply the x plus 2 by an additional x plus 2 to make it squared, but I can't multiply the x plus 2 squared by something to make it to the first power. I would have to divide, and that wouldn't actually work out here. The only other factor that is unique is the x plus 3. So my least common multiple is x plus 2, the quantity squared, times x plus 3. For part B, we have three different polynomials. The first one, x cubed plus 9, x cubed minus 9x, I can factor out an x. I'm left with x squared minus 9, and then x squared minus 9 actually factors into x plus 3x minus 3. So that's the first polynomial. The second one, x squared minus 2x minus 15, that factors into x minus 5 and x plus 3. And then the last one, the x squared minus 5x, we can take out an x, and we're left with x minus 5. So every factor has to be present in our answer. The first factor that I have is an x. Well, there's an x with the first one, there's an x with the last one. They're both to the first power, so the first power is what I'm going to use. My next factor is x plus 3. That appears with the first and with the second. So again, those are to the first power, so I'm going to have an x plus 3 to the first power. X minus 3 is my next one. And that first polynomial is actually the only place that the x minus 3 occurs, but it still has to be present in my solution. And then that does it for the first polynomial, so now I have to look at the second polynomial and see if there are any factors there that I have not addressed yet. Well, I haven't used the x minus 5 yet. And again, x minus 5 occurs with the second and with the third to the first power, so first power is what I'm going to use. X plus 3, I've already used the x plus 3, so I don't have to use it again. And that does it for the second polynomial. With the third polynomial, x, I've already used the x, and x minus 5, I've already used the x minus 5. So my least common multiple is x times x plus 3 times x minus 3 times x minus 5. Whenever you are making your fractions have common denominators, you're going to be multiplying your fraction by the piece of the least common multiple, or we're going to call it the least common denominator, that is missing. So here is example 3. What is the sum? Again, sum is going to be addition of x plus 3 over x squared minus 1 and 2 over x squared minus 3x plus 2. So I'm going to write those out. I am going to factor. So the first one, denominator factors into x plus 1, x minus 1. The second is going to factor into x minus 2, x minus 1. And now I'm going to look at the least common denominator. We can switch out multiple for denominator because now we're talking about the bottom of our fractions. So I want to look at every factor that's present. Well, there's an x plus 1, there's an x minus 1, and then the only other unique factor is x minus 2. So all of those have to be present in my solution. The first fraction has the x plus 1 and the x minus 1, but it is missing the x minus 2. So I need to multiply by the x minus 2 on the bottom. And to keep things balanced in a fraction, whatever you do to the bottom, you also have to do to the top. Because multiplying by x minus 2 over x minus 2 is the same thing as multiplying by 1. And when you multiply something by 1, it does not change value. The second fraction has the x minus 2 and it has the x minus 1, but it's missing the x plus 1. So I have to multiply it by x plus 1. On the top, we have to FOIL this first fraction. That's going to give us x squared plus x minus 6. The second fraction, and I'm actually going to write the denominator of the second fraction in the same order that I had for the first one, just to make it a little bit easier. I'm distributing the 2, so it's going to give me 2x plus 2. And then I have to go through and combine like terms. So my denominator is going to be x plus 1, x minus 1, x minus 2. Do not multiply the denominator together. It is not necessary to get a single polynomial, and that's just way more work you're creating for yourself, and you're more likely to make an error that way. So leave your denominator alone. However, the numerator you should FOIL and combine just in case it would factor, and you can reduce factors top to bottom like we did back in 4-3. So there's only one x squared term. X plus 2x is 3x. Negative 6 plus 2 is minus 4. So let's look at that. X squared plus 3x minus 4, that factors. X squared is going to factor into x and x. Factors of negative 4 that add to make positive 3 are going to be negative 1 and positive 4. And hopefully you should notice we have an x minus 1 in the top and an x minus 1 in the bottom. Those actually add out. Or I'm sorry, not add out, divide out. And then our final answer is going to give us x plus 4 over x plus 1 times x minus 2. And that would be our solution. You don't need to put the x plus 4 in the numerator in parentheses because it's the only factor there. However, if there had been multiple factors left in the top, then you would need parentheses to separate those. And it's not always going to work out like this. It's not always going to work out that you can factor the numerator and divide out with what you have in the denominator. Sometimes you can't factor the numerator, whatever you get, and sometimes you can factor it, but nothing is the same. So just know that this will happen occasionally, but not often. So this is where I'm going to conclude the part 1 video, just to keep these a little more manageable in time. Go back through and rewatch anything that you're not sure of and reach out to me if you have any questions.